In this tutorial, we'll work through the screen compensation node group that is used in the AutoShot post-cure node group to remove green screen lighting variations. This technique is described in Steve Wright's book, Digital Compositing for Film and Video, and in his LinkedIn course, both of which I absolutely recommend. Links are in the notes. As a refresher, first Control-Shift left-click on the camera original, and then the ScreenFixPost node. And note that the green variations just disappeared from most of the green screen. Note that we can zoom in and we still have soft edge transitions, except for some 420 keying artifacts over here. So how does this work? First, Control-Shift left mouse button on the AI Matte node, and then on the Dilate Erode node. Note that this feeds into the core matte of the ScreenFixPost, along with the camera original for the camera EXRs and our green screen background pick color. All three are going into the ScreenFixPost node. Okay, so with the ScreenFixPost node highlighted, hit Tab to dive in. And here we can see the insides of the ScreenFixPost node. This looks tricky, but we'll go through it step by step. First, Control-Shift left mouse button through the outputs of the group input node group. Note that you can see core matte, which we're getting from the eroded AI matte, the camera EXR, which is the camera original, and finally the key color from our previous green screen color pick. Next, look at the output of the source key node. Control-Shift left mouse button. You might have to cycle through the viewer nodes a couple times with Control-Shift left mouse button to wake up the viewer. The source key is made to cut out the actor from the background. It's intentionally dialed up with a dilate setting set to 9 to add on to the edges of the foreground element we want to keep. So we're trying to make a key that covers all of the actor, and we'll see why very soon. Next, let's look at the invert node. This is connected to the matte output of the source key, and it inverts it. Now we'll move to the set alpha node. The set alpha node uses the inverted matte and applies it to the original green screen background, and uses the invert node, and so we get a green screen background with the character cut out. Next, we move to the alpha convert node. And what this has done is that it has removed the premultiplication of the edges of the image so that the edges of the image are not darker than the actual background. If they were still premultiplied, they would be somewhat darker. Now we move to the inpaint node. Oh, okay. What's happening is that it's using the existing colors. This has got a distance of 96, so we'll go back to 10. And so it starts here, and as we go larger, it inpaints using the existing colors and fills in the holes in the image. So we'll go all the way back up to where we were. And it doesn't need to actually be perfectly closed because we're just going to use the edge of this. And what's happening is that we're now making a clean plate from a shot that never had one on a per frame basis. So this is going to lead to some pretty cool magic. Now we come to the twin keyer nodes. And the important thing here is that both of them have exactly the same parameters. So they both have exactly the same despill, they have the same clip black and clip white, 0 and 1, and the top one is fed by the clean plate that we created. So here's the clean plate going into our image of the top keyer, and the bottom one is fed by the core matte and the camera EXR. So there's the camera EXR going down to our image. Here's our key color going into the key color, and our core matte is coming from our AI matte. And so then if you look at both of these, zoom back our viewer a bit, if you go back and forth between them with the viewer node, you'll see that we have a matched key with the same partially transparent artifacts on the green on both keys. So there's a little bit of a partially transparent artifact here, and here it's almost exactly the same. Now we're going to move on to the invert nodes connected to the matte outputs of both. So here's the invert node of the matte output of here, and the invert node here. So we have our actor, but with the same background lighting variations. Now we're going to move on to the divide node. And what the divide node does is it multiplies the matte signal of one inverted matte by 1 over the matte signal of the second inverted matte. So now we have a nice clean cutout of the actor. And the combine color node, which is next, simply splits the float value of the divide node into separate RGB channels that we're going to use in the next step. Now look at the subtract node. This is subtracting from our inpainted image. It's subtracting our key color. And so what that gives us is a map of the screen color variations between the camera original and the constant green color. This is where it's getting darker or lighter. If I right click on this, you can see that we have negative and positive green screen and red, green, and blue values as we are calculating the variations between that constant green color and the actual screen lighting variations. Now, the multiply node then just punches out the actor-shaped hole in the screen correction map. So we're going to click that, and now we have our hole where the actor was, and actually where the stage is, but we'll correct that later. And finally, we add this back to the original camera image, the add node, and poof. And the result is a remarkably even green screen. Note that since the twin matched keys were not pushed to amplify the clip black and clip white levels, we don't want to do that. Those are left at default levels. Then we've retained our soft edge transitions to a surprising degree, especially considering 420 footage, which is what we're working with here. This will work much better than cranking a single stage keyer to get rid of the background wrinkles. Tab to jump up a level and highlight this. And we'll note that our resulting green level is almost identical to the level of the original green pick color. So if I right mouse button click my green screen, I've got these RGB values. Green is 0.192, blue is 0.034. And we're going to look at this. And there's our green, 0.192, blue is 0.034. Yep. 0.034, red is 0.01. Yep, 0.01. Great. So it's a very close match. All right, next we'll wire in our tracked 3D garbage matte to remove the stage.